Welcome to the Explainer. You ever wonder how your favorite app can just find your data in a blink among millions of other people? Well, today we're pulling back the curtain on the secret sauce that makes it all happen. We're talking about hashing.
Okay, so to really get why hashing is such a big deal, let's start with a problem we all know and hate: waiting for a slow, clunky search to finish.
Right, think about it. Trying to find one specific piece of information in a gigantic database, it's like trying to find one specific grain of sand on an entire beach. So how on earth does a computer find exactly what you're looking for without taking, forever? Well, the old-fashioned way is, frankly, painful. It's like wandering through a library with no catalog system, checking every single book one by one. But hashing? Hashing is like having a magical GPS that takes you straight to the exact book you need, no matter how huge the library is. And here's the real magic of hashing. Its speed is just incredible. It almost doesn't make sense. It doesn't matter if you have 10 things to look through or 10 million. Hashing finds what you're looking for in basically the exact same amount of time. You give it a key, say your username, and it instantly finds the value, your profile. It's an absolute superpower for finding data. So, how does this amazing shortcut actually pull it off? Well, it all comes down to this really clever but surprisingly simple idea called a hash function. Think of a hash function as a super smart, lightning-fast mail carrier. You give it a letter, which is your data, and it just instantly knows the exact mailbox where that letter belongs. There's no hesitation, no sorting through a giant pile of mail. Let's actually watch it work. So we start with a key, like the name Suresh. The hash function takes that name, runs it through a special mathematical recipe, and boom, it instantly spits out a unique address. In this case, that's 84. It's like giving the name Suresh its own secret map coordinate. Now, a good hash function is like a perfect party host. First, it's got to be fast and efficient, obviously, but the most important job, it needs to try and give every single guest, every piece of data, their very own unique seat. Because if two guests try to sit in the same chair, well, that's when we get a problem called a collision. So what happens when that party gets a little too packed? What happens when our perfect host just runs out of unique seats? This is where the magic of hashing faces its single biggest test.
All right, imagine our hash function finds a perfect spot for our first piece of data. We'll call it key A, at address number 7. So far, so good. Everything's working just like it's supposed to.
But then a totally different piece of data, key B, comes along. The hash function does its math and oh no, it wants the exact same spot, address number 7. Now we have two different things trying to squeeze into one spot. This, right here, is a collision. And this is where it gets really, really tricky. You can't just throw out the first piece of data to make room for the new one. That would be total chaos. So you have to figure out a way to solve this and keep everything nice and organized. This is really the ultimate test for any hashing system. If you can't solve this problem cleanly, the whole thing just grinds to a halt, and your super fast search suddenly becomes slow again. Luckily, some very smart people have come up with some pretty clever ways to handle it. Okay, so how do we deal with these collisions and stop our data from turning into a big mess? Let's look at two of the most popular and honestly pretty brilliant strategies. So you've basically got two main choices when you have a data pileup. You can either start a little waiting list right there at the crowded spot, that's called separate chaining, or you can just go looking for the next empty seat nearby, a method we call open addressing. Separate chaining is kind of like the waiting list at a super popular restaurant. It's a pretty simple idea, and the good news is you never really have to turn anyone away. But there is a trade-off. If that waiting list gets way too long, well, it can take a while to finally get seated, and our search starts to slow way down. Now, linear probing is a type of open addressing, and it's a lot like trying to find a parking spot in a really crowded lot. If the first spot's taken, you just check the next one. That one's taken, you check the one after that, and you just keep going until you find an empty space. Pretty simple, right? But yeah, that simple approach, it has a catch. It can lead to these weird traffic jams where all the parked cars end up bunched together in one area. They call this clustering, and it makes it much, much harder and slower to find an empty spot later on, which can really bog down the whole system. So now that we've seen how hashing works its magic, and importantly, how it deals with its biggest problems, let's talk about how this amazing tool is secretly powering pretty much everything you do online. Hashing is truly the unsung hero of our digital world. It's the reason your social media feed loads in a flash. It's how your computer finds a file in an instant. It's what makes your web browser feel so snappy by caching websites you visit often. It is the secret ingredient that makes our digital lives feel so seamless and fast. The holy grail, the absolute ultimate goal of hashing, is to achieve what computer scientists call constant time access. And all that means is the promise of instant data retrieval, a predictable, reliable speed that doesn't change no matter how much data you throw at it. It's the reason our digital world feels so incredibly responsive. So when you boil it all down, hashing is basically a one-way street. It is designed to be super easy to go from your data to its address, but almost impossible to go backwards. Now, that one-way design is the key to its speed, but it also opens up some fascinating possibilities and challenges. It makes you wonder, what else can you do with a system that's designed, from the ground up, to be a permanent, unbreakable secret code?